All right, avoiding access types, how and why. First, some terminology. The main issue with access types is memory management. And there are also access to subprogram types where you don't really have memory management problems. So in here, when I say access types, I'm referring to access to object types for short. Okay, I like to say that in Ada, access types are never needed. Of course, that's not 100% true. You need a little bit of a disclaimer. But in a lot of cases, you can replace them simply with unbounded components from the standard library. And in other cases, where they're really needed, you can often encapsulate and hide them in a custom component. And we'll discuss that a little bit later. So I'm going to show 3 cases here where people have often used access types, and I tried to avoid them. So the first case is returning large objects. If you have this type here, depending on what it represents, the object can be arbitrarily large and has to be allocated on the heap. And there's a lot of verbiage here, but it comes down to deliberately and directly allocating it on the heap can cause problems with memory management. And most of the workarounds to that are not very convenient. So one thing you can do is to use a holder rather than use a function, which you have to use here because you don't know till you read it how big it's going to be. The holder, you can use a procedure. Now you do have a certain amount of use of access types in this case. But since you then immediately stick the object in the holder, you can do the memory management there. The memory management is very simple, and you can be reasonably confident that you get it right. If you need more complex memory management, then this is a case where you could use a custom holder, basically. And you would have an operation in that custom holder where you tell it how big the thing needs to be, and it does its own allocation, hides that from the rest of your system. Is that clear? Okay. The second case is called making private types private, and that sounds sort of like an oxymoron, I know. But in 883, the full type is only visible within the package where it's declared. 895 added child packages, which allowed visibility of the full type in descendant packages. And this is sometimes desirable, but sometimes it's not. For example, if you have a complex record with constraints between the fields, you might want to limit changes to the record to being done by an operation that enforces those relationships. And in fact, we have here on Stack Overflow a question from a couple of years ago from somebody who had basically that same thing. And the first answer that you got used, let's see, used access types and did some memory management. And the interesting thing about this is that the memory management is incorrect. And I'm sure that answer was not posted maliciously. And this is a fairly simple and straightforward instance, and yet it's still difficult to get the memory management correct. And so that's a good argument for avoiding the use of access types if you can. Then some guy named Carter posted alternate response using holders. And in this case, okay, what have I done here? Never mind. You start off with an abstract tag null record, and you implement the holder on the class-wide type. Then your full type just has a holder. And in your package body, you extend this tag type to be your real full type. Now the child packages can only see this, and they have no idea what you're putting in it. And in the body, you can store an object of this real type in the holder. When you retrieve it, you've got a class-wide type, and you need to convert that to the real type. But since this real type is the only extension of the root type, and the only thing you're putting in the holder, that's a safe operation. Now this equals is necessary because class-wide types have no primitive operators or operations. And for some reason, the indefinite holders requires an equality operation. I'm not sure why, because I can't see any use of equality in a holder, but there you are. The Gnats I've been using will actually handle an instantiation without an explicit equality parameter and without defining your own. But I think that's an error. We good? And the final case, and probably the most complex, is self-referential types, where they contain components of themselves. Now, for a simple example, we have the binary tree, which conceptually is this. Of course, that's not legal eta. And something I didn't get to in that making private types private is why we use the class-wide type. You would think that you could do this. Use the incomplete private type to instantiate indefinite holders. But this is not allowed by the language. Incomplete private types are a special case which have extra restrictions. And that's why you use the class-wide type approach, which is very similar here as it was in the making private types private. And again, you have to convert types that you extract from the holder to the actual type tree in this case. Now, all these examples have used holders, and holders are quite useful, but for self-referential types, it's often useful to instantiate other components. So, for example, you have the type called an S expression, which contains a list of S expressions in it. And so for that case, you might want to instantiate the indefinite doubly linked list package on your class-wide type, so that you can then have an object of that list type in your full type. Okay, just to show that I'm not talking out of some other orifice than my mouth, I created a full implementation of unbalanced ordered binary trees using holders. I don't know that that's an approach that would be a good way to do it for real world use, but it does work. So how am I doing for time?
Pretty good.
Pretty good.
Hmm.
All right. So in summary, we see that avoiding access types can enhance the correctness of programs simply because memory management is so difficult to get correct. And when you avoid the access types, you avoid the memory management. And so that's a positive. And it's also often less effort than implementing correct memory management to take this route. I guess I'm done.
Oh, thank you. Are there any questions that you would like to ask regarding access types or these approaches or anything really? Yes, Alex?
It's not a question, but I wanted to say that the last point about using complex structures with the class-wide approach, I did that for a layer, for the structure that holds dependencies, because I also would like to avoid access types as long as I can until I see a real impact in performance. And at least in a layer, it has worked very well. You don't notice any impact, and it's actually quite comfortable to use
All right.
this kind of approach.
In some of the in the ImageIO library that I worked on, I created a couple of custom holders so that I could do the allocation in the holder, and the rest of the system doesn't have to worry about messing with access types. I didn't notice any impact from that.
Actually, I'm thinking that there is no access types visible at all in a layer at any point.
Right.
Are there any more comments here or questions in the room? Maybe online too?
Just a comment
here.
as well that basically this is another example of raising the level of abstraction. That instead of doing something relatively low level yourself as implementer, you use the facilities that are provided by the programming language, where it's implemented by the compiler of the runtime. Once that's good to you, you can use that instead.
Yeah, we assume that we can trust the standard component library.
Let me add that in Rust also the predefined structure are unsafe pointers. So when they do exactly the same, relying on unsafe pointers, supposed to be well designed. So Rust is nowhere safer than Ada on the handling on pointer.
That has been my impression. There's a paper somewhere that shows data races in safe Rust. And so I don't really see an advantage to using Rust, and Rust being a low-level language that emphasizes ease of writing over ease of reading, I see no reason why anyone would want to use it.
Yeah, a small comment.
Yes.
The last line on the second code example there.
Yes.
You say v.value.element.
Yes.
You could probably use constant reference instead, which would avoid a copy of the data.
Yes, if you, it depends on what you're doing. If you're applying an operation, you'd probably use query element or update element, something like that.
Yes, but in this case, you return a copy of the element and then you make another copy. If you just used constant reference, you would avoid one copy.
Yeah, I'm not all that interested in avoiding copies.
Okay.
When I do, I usually use a subprogram. It's passed by reference that way.
Yes, but returning large objects on the stack
Mhm.
and copying them multiple times will give you trouble at some point.
At some
I
point.
know.
Yeah, you don't want to put them on stack. That's part of the point if they're large. That was the first point of avoiding returning large objects.
We have
First,
some questions from the
thanks, Jeffrey.
remote.
We have
Yes.
questions online. If you would like to ask them. Oh yeah.
I can read the question. So the first one is, did you run into performance issues when you had to manage many objects using the holder method?
Using the what?
The holder method.
The holder method.
Ah, you didn't hear. Okay. If he, the question was if he ran with any issues, performance issues, when he used the holder method.
Well, I never encountered anything that prevented me from meeting my timing requirements. And in some cases, if you use a custom holder, you avoid a copy, and it might even be a little faster.
Okay. Next question. So it's a bit long. The problem with holders and other smart pointers is that there is no not null convenience syntax. There is no subclass restriction easily available. What do you think about adding smart pointer logic directly on access types? Question marks.
Well, you can build your own smart pointers. I did reference that, although I didn't really mention it in the talk. Where was that? In returning large objects, that you can use a smart pointer, and then the return expression would return what the smart pointer points to, and then the finalization on the smart pointer would deallocate the allocated memory, and that would avoid the problem of using a pointer, an access type directly within the function. But your problem there is that although you've avoided the memory management, you're then still returning something quite large to your client, and the client has to be able to deal with that. And that will either force the client to use something like access types, or if the client is not careful, might result in a stack overflow.
Did that answer the question, hopefully? We have a question here in the room.
Yeah, thank you. Well, it's more a comment. Well, first, thank you very much, Jeffrey, for these wonderful insights of your presentation. And it's very useful intellectual ammunition for us that love Ada and are kind of disappointed of seeing like Rust getting in the way to Ada for more widely adoption. I believe that what the concept that you have explained is so relevant, because the problem with Rust is that is to me is a band-aid for a fundamental thing that has gone wrong for many years, since C, like making pointers so like prominent in the language, which is kind of wrong, right? And then you end up having to put band-aids to limit the dangers of pointers, instead of going back to the fundamental principles of what Ada was designed like. And So that's great. That's great. And so, is there a paper that where you have kind of more details of what you presented?
So I got this. It's a draft, really. It's not ready for prime time, but this paper is self-referential data types without excess types on GitHub.
Oh, thank you. Yeah.
And if you look here, you can see that I've been beating this dead horse for at least 6 years.
Maybe I can use the occasion now to mention that all the presenters at this workshop will be invited, if they want to make the effort, to write down an overview of their presentation here, or that could be a full paper if you want to, which will be printed in or published in the Ada User Journal afterwards as a kind of proceedings for this workshop. Of course, we depend on the voluntary effort of the presenters to do even more than just present, but we thank them in advance.